Hey, lovely viewers, welcome to another interesting and fascinating math video. In this video, we are going to be taking a look at a problem on progression. So let's go see the problem and go through the solution together. So we have here that if A, B, and C are in harmonic progression HP, we are to show that 1 upon A plus 1 upon C equal to 1 upon B minus A plus 1 upon B minus C. So guys, before we delve into the solution, there are basically three types of progression: the arithmetic progression and geometric progression, which we are all familiar with, and harmonic progression. So the harmonic progression is the inverse of the arithmetic progression. So HP equal to inverse of AP. And we know that the number of terms in an AP is given by A plus n minus 1 bracket D, where A is the first term, n is the number of terms, and D is the common difference. So we can then say that the number of terms in an HP, I can call that one Hn, is equal to the inverse of the number of terms in an AP. I will say 1 upon Tn. I think this makes sense. Okay, from the problem, we are given that A, B, and C are in harmonic progression. So it implies that the inverse of A, B, and C are in arithmetic progression. So I will write, okay, because this implies that 1 upon A, comma, 1 upon B, and 1 upon C are in AP. AP is what we are used to. Now in an AP, the arithmetic mean of these three terms is going to be 1 upon B, which is the sum of 1 upon A plus 1 upon C, all divided by 2. So if I multiply both sides by 2, I'm going to be having 2 upon B equal to 1 upon A plus 1 upon C. So we shall call this an equation. I'll come here to say 2 upon B, which is 1 upon A plus 1 upon C. I will call this one equation star. Then the constant term in an AP, which is the common difference, can be gotten by the difference between two consecutive terms. So the difference between these two guys here and these two guys here is actually constant. So that's going to be 1 upon B minus 1 upon A equal to 1 upon C minus 1 upon B minus 1 upon B. Okay, so this is the common difference or the constant term. So if we operate on these fractions using the butterfly method, it's going to give us A minus B upon AB equal to B minus C upon BC. Guys, we are just being rational and logical. A, B, and C are in HP. Therefore, implies that 1 upon A, 1 upon B, and 1 upon C are in AP. So the AP gave us this expression here. So if we take the inverse on both sides, we then have HP. So if we take the inverse of these two fractions, we are going to be having AB all over A minus B equal to BC all over B minus C. So this makes sense, perfect sense. So B is common on both sides, so I can then have A upon A minus B equal to C upon B minus C. Now, we already have the left side of this proof, which is our equation star. So 2 upon B is equal to 1 upon A plus 1 upon C. Now, you can see that the right side of what we are looking for, somehow, one of it is here, B minus C. So we are going to play tricks on this very expression here so that we can get the desired results. So to do that, we are going to bring creativity and logical reasoning into things here. So we can say, okay, A plus B minus B upon A minus B is going to be equal to C plus B minus B upon B minus C. So with this, our homecoming, I'm overexcited, our homecoming is guaranteed. So B minus B is 0, B minus B is 0. So we've just refined this expression and tailor it to our need. I don't like to use the word manipulation in mathematics. So I will take off this part of the board so that we can finish this job. It's a nice problem, different from what we know. So the next thing I'm going to do is try to split this fraction. Okay, the cover of the marker just fell, so we can manage that. So I'm going to be having A minus B, okay, upon A minus B. I'm actually splitting this fraction to 2, then plus B upon A minus B. So you can see what we are having here. It's actually very productive. I will also split the right side. We are going to be having, okay, here we'll be having, okay, C minus B upon B minus C. Then we are having plus B upon B minus C. So you can see that this will cancel out to give 1. Then we are going to work on this guy and this guy. So we'll then be having, okay, if I put a negative sign there, it can help because that will help, change the denominator to our desired result. So if I multiply both sides of this fraction here, I'm going to be having 1 for this guy that cancels out. I'll put a negative sign here. I'm going to be having minus B all over B minus A. And guys, you can see that B minus A is in our main proof. Okay, then here, I'm still going to do the same thing here. So if I multiply the numerator of this fraction by -1, I will now have the same with the denominator. So I'm going to be having negative C plus B all over B minus C plus B upon B minus C. Okay, it's moving on very well. Then I can then rewrite everything again. 1 minus B all over B minus A is going to be B minus C upon B minus C plus B upon B minus C. So guys, you can see the logical reasoning here. So at the end of the day, this guy will also cancel out to give 1. B minus C cancel out B minus C. We'll then be having, okay, and here we are going to be having, mind you, there's a negative sign outside this place. I didn't remember to put that. So 1 minus B upon B minus A should then be equal to B upon B minus C. Then minus 1. So if I take -1 this way, it becomes positive. If I take negative B upon B minus A to the right, it becomes positive. So I'm going to be having 1 plus 1 equal to B upon B minus C, then plus B upon B minus A. So you can see that we are gliding toward the answer. So I'm going to be having 2 equal to B upon B minus A plus B upon B minus C. So guys, you can see that these two guys are actually on the right side of what we are proving. So, and again, you can see B here. We have to get rid of that B. And we can do that if we multiply both sides of that equation by 1 over B. So I'm going to be having 2 equal to 1 all over B minus A plus 1 all over B minus C. Okay, I'll put this in parentheses, multiply B. This is interesting. And if I multiply both sides by the inverse of b, I'm going to be having 2 upon b equal to 1 upon b minus a plus 1 upon b minus c. Then the b will cancel out. And from our equation star, we can see that 2 upon b is equal to 1 upon a plus 1 upon c. Therefore, we can then say finally that 1 upon a for 2 upon b plus 1 upon c is going to be 1 upon b minus a plus 1 upon b minus c. So our QED, quadra et demonstratum, what needs to be proved has been proven. So guys, we've come to the end of another interesting tutorial. Please ensure you give this video a like and make sure you share with your learning friends and colleagues. And more importantly, or most importantly, ensure you subscribe to join this community so that you wouldn't miss out in our next video. See you next time, and God bless.